This video is for Pythagorean theorem word problems. So the problem on the front of this foldable says Bobby leans a 15-foot ladder against his house. The base of the ladder is placed 4 feet from the base of the house. How far up the house does the ladder reach? So for this one, you've got to draw a diagram. Draw yourself a triangle. So here's my wall, here's my house, and it says that I put the ladder 4 feet from the base of the house. So here's the base of the house. Here's the bottom of the ladder. So I know this distance here is going to be 4 feet. And then the ladder, the length of that ladder is 15 feet. So what I've done is I've created a right triangle, and so I can label my pieces here. And so what I'm looking for is how far up on this house, up here, does that ladder reach? So we're missing a leg value. So this is the formula that we're going to use. So c squared is the hypotenuse, so that's 15, and then minus the leg squared. And if you type all that in your calculator, you're going to get x is approximately 14.5 feet. Okay, our next problem says Jane and Zachary start walking at the same point, but Zachary walks 5 feet north while Jane walks 75 feet east. How far apart are Jane and Zachary when they stop? So here's what I know. Zach's going to walk 5 feet north. Jane is going to walk 75 feet east. And so if you look back at the diagram, your bottom leg of your right triangle is going to be moving east or west. Your upright leg is going to be north or south. So A is moving north or south, B is moving east or west. So Zachary walks 5 feet north, so if they both start at that right angle, Zach's going to walk 5 feet north. Jane's going to start at the same point, but she's going to walk 75 feet east. So again, we're going to use the formula. We're going to do the square root of one leg squared plus the length of the other leg squared. And so and that's going to equal x, which is how far apart they are when they stop. Because Zach will be here, Jane will be here. So you want to find the distance between the two. So if you type all this in your calculator, the square root of 5 squared plus 75 squared, you're going to get x is approximately 75.2 feet. All right, the next question. The length of the diagonal of a television is 20 inches, and the height of the screen is 12 inches. Which of the following is the width of the television? All right, so I know I have a diagonal of 20 inches. So when you're thinking of a diagonal on a television, so here's my TV. The diagonal is from one corner to the other corner. So in my little diagram here, what I've done is I've just cut off half the TV. So the diagonal is going to be your hypotenuse. The other thing I'm given is the height. And the height is 12 inches, so the height is how tall your TV is. And then I'm looking for the width. So this time I've got a hypotenuse and a leg, so we use the formula, the hypotenuse squared minus a leg squared, and then we square root that. So if you type that into your calculator, 20 squared minus 12 squared, and then you square root it, you're going to get that x, the length or the width, is going to be 16 inches. All right, next question. A 14-foot ladder is leaning against a building. It is 5 feet away from the wall. How high up the building is the ladder? All right, so I've got a 14-foot ladder, and I know that it's 5 feet away from the wall. So here's my wall, and so I know that the base of the ladder, which is right here, is going to be 5 feet away. So this is 5 feet, and then I know the length of the ladder, which is the hypotenuse, is 14 feet. So I'm looking for how high up on this wall that ladder is going to reach. So I have a hypotenuse and a leg, so we're going to square root the hypotenuse squared minus the leg squared. And so again, if you type this into your calculator, the square root of 14 squared minus 5 squared, you're going to get that x is approximately 13.1 feet. Okay, Cindy goes to visit a friend. She travels north for 20 miles and then turns west for 25 miles. Her friend tells her to turn on a diagonal to go back home. How far did Cindy travel? So remember that the up and down leg, the vertical leg, is our north or south. And then the horizontal leg would be east or west. So this would be 20. This one would be 25. And then she tells her to go back on a diagonal. So again, that word diagonal typically means our hypotenuse. So that is what we're looking for. So the formula here would be one leg squared, so 20 squared, plus the other leg squared. So if you type that into your calculator, the square root of 20 squared plus 25 squared, you're going to get that x is approximately 32 miles. All right, our final question. Troy is building a rectangular garden that is 10 feet by 6 feet. What should be the length of the diagonals to ensure a 90-degree angle? So what you're trying to do here is to make sure that you get that right angle in there. So it's going to be 10 feet by 6 feet. So again, if we build a rectangle and we build it 10 feet by 6 feet, the diagonal is from one corner to the other. So again, I've just cut off the top part of my garden here. And I've created a right triangle. So I have two legs. So our formula is the square root of one leg squared plus the other leg squared. So 6 squared and 10 squared. So if you type that into your calculator, the square root of 6 squared plus 10 squared, x is going to equal the square root of 136, or x will be approximately 11.7 feet. So the key here is to make sure that you're drawing diagrams for those story problems so that you're seeing where the pieces fit in. And that's it for this video.